Okay, so what we want to do today in our section, our unit on quadratics, is to solve quadratic functions, but we're going to do that by factoring. Okay, so let's take a look at the do now, which should be a review of things we've done before. X squared minus 25. You should see that both terms are perfect squares. It's a perfect square, x squared and 25. And as you learned with dots, which is the difference of two squares, it can be factored as x minus 5, x plus 5. The second one, you learned to factor using that I am method, what adds to negative 5 and multiplies to negative 14. And hopefully you'll see that factors as such. And then the third one, you should see that the first thing you want to do is factor out the GCF of 3y, so that you're left with y squared plus 6y minus 16, and then you take a look and see that you can still factor y squared plus 6y minus 16 by using the I am method. Now, one of the things that you have not learned that we're going to first cover today is factoring when the coefficient of x squared is greater than 1, and I cannot pull out a common factor. And we call this the AC method. And what we're going to do is we're going to use that grouping method that we previously learned to do this. And you'll see why in a moment we call it the AC method. Okay? So we want to factor the trinomial 3x squared plus 10x plus 8. And here are the steps that we're going to walk through. Step 1 is we want to multiply the a and the c. Well, a is 3, c is 8, so 3 times 8 is 24. Okay? Now, step 2 is we're going to use the I am technique to see what adds to b and multiplies to AC instead of just C. So what adds to 10 and multiplies to 24? Right? Those are two pretty straightforward numbers. Next, we're going to rewrite the trinomial with new terms, and this is where the let me just scroll here, sorry about that. This is where the grouping method is going to come in. So we're going to rewrite the trinomial with the new terms for b. So now it's going to be 3x squared, and instead of 10x, we're going to use the 6 and the 4, plus 6x plus 4x plus 24. I'm sorry, plus 8. Now, if you write and remember, in the grouping method, what we did, so we're going to factor by grouping, is we took the 4 terms and broke them into 2. So I factored the first part, 3x, x plus 2, and then the second part as 4, x plus 2. Remember, the key was to get a common binomial, and now I have 3x plus 4 times x plus 2, and we've now factored that trinomial. Okay? So let's go through the next example. All right. A times c is equal to negative, well, let's do it like this. Easier. I need to add to 2, and I need to multiply to negative 63, which is 3 times negative 21. Okay, hopefully you'll see that's 9 and negative 7. So I'm going to write this as 3x squared plus 9x plus minus 7x, sorry, minus 21. Again, it doesn't matter whether the 9 comes first or the negative 7 comes first, it will still factor correctly. I got 3x, x plus 3, and I have to factor out a minus 7 to get an x plus 3. So my final answer is 3x minus 7 times x plus 3. Remember, you can always check if you factored properly by multiplying what your resulting factors are. Okay. Now, how do we solve quadratic equations when we're looking at trying to factor here? Okay. If the equation can be transformed into the form ax squared plus c equals 0, and it can be solved by using square roots. And I'm just going to add the following, meaning there is no b, or b is 0. All right, I'm going to show you an example of that in a couple of minutes. Now, if the equation can be transformed into ax squared plus bx plus c, then look to factor using one or more of the following methods. Now, in every factoring problem, we want to determine if there is a greatest common factor that is common to all the terms and factor it out. Determine if the remaining polynomial can be factored using b through d below. If the equation is a binomial, then look to factor by using dots, difference of two squares. If the equation is a trinomial, wherein a equals 1, then look to factor by using I am. And if the equation is a trinomial, wherein a is greater than 1, look to factor by using AC. Set each factor equal to 0 and solve. Okay, the last thing you've got to be careful about is determine if there are any extraneous solutions. These are solutions that either make the denominator equal to 0 or are an inappropriate numerical or are inappropriate numerical values. So in other words, when we get to word problems, for example, it's a situation where you have an answer that just doesn't make any sense, like negative length or something like that. All right, now let's solve each quadratic. Now the first one can be done a couple of different ways. The first way is I could factor out the 3, and I get x squared minus 25 equals 0. And then I can factor it by using dots. And I get x is equal to negative 5 and x is equal to 5. Okay? Now, the other way you can do this is by just solving it almost like you're solving a linear equation. In other words, isolate the variable. Now, if x squared is equal to 25, I want to take the square root, and the square root of 25 is both positive and negative 5. So either method works. The one thing about the method here in blue is if this number does not work out to be a perfect square, you would not be able to use dots, but you can always use the method in blue. Okay? In the second one, it's already factored for you. So I just set each side equal to 0. Okay. The third one, please remember that you have to set your quadratics equal to 0. set each one equal to 0. Okay. The next one, again, we're going to just factor. And in a moment, I'm going to show you how to use the calculator to check your answer after we've done these. Okay, now hopefully you see here that you can factor out just an x. You still have two answers. Remember, in quadratics, you're looking for two answers because the exponent of the variable is 2. Okay, continue on with our examples. In this one, hopefully you see you can factor out a 2. Oh, I'm sorry, let me do this first. Okay, put them in order of ax squared plus bx plus c. It definitely will make your life a lot easier. Now, this 2 out here is inconsequential for figuring out our answer, even though I'm just going to carry it down. It's critical if you were factoring, because if it weren't there for factoring, it would be an incorrect answer. Now, I got to clean this whole thing up. You want to try to keep the x squared positive, so I'm going to get rid of that x squared. I'm going to add that x. I'm going to subtract that 10x, and I'm going to do the same thing on the other side. It's not as clean here because I can't really line everything up, but hopefully, and actually what I should have done first, I apologize here, is I should have consolidated this into 3x squared plus 9x, and then get rid of the 3x squared and the 9x. And so my resulting trinomial is x squared minus 9x plus 20 equals 0. And then I'll factor that as x minus 4, x minus 5. And it helps to write what I'm saying. Okay. And the last two, I'm going to subtract 3n squared and 100 on both sides. So I get 4n squared minus 100 equals 0. I can actually then say 4n squared equals 100. Divide by 4. N squared equals 25. And the square root of that n is plus or minus 5. Or you could have done dots. Lastly, you've got to cross multiply. We've seen this a number of times. 2x squared minus 6x equals x squared plus x minus 6. Get everything over to one side. Just give myself a little room. So x squared minus 7x plus 6 is equal to 0. X minus 6, x minus 1 is equal to 0. X is equal to 6, x is equal to 1. I got to go back and take a look, since I started with fractions, and see if either of these two make that zeros. No extraneous solution. Now, I want to show you one of these by using the graphing calculator. And the one thing I want to point out is the only downside to the graphing calculator is the equation has to be set up where it's set equal to 0. So in other words, if you looked at the problems 6 through 9, none of them are set up equal to 0. So if you don't correctly set it up equal to 0, it's not going to be helpful on the calculator. But let's take a look, for example, at number 6. We eventually got it to be 2x squared minus 6x plus 4. All right, and we found our solution set to be 2 and 1. Well, how do we check that? We call up our table of values, and if you look here, when x is 1, y is 0. When x is 2, y is 0. So that's telling us that we correctly factored that trinomial. Okay? So, just to quickly recap, today we worked on solving quadratics mainly by factoring, setting the equations equal to 0.